If you're spending thousands of euros on waste management, in this video, we'll explain how vacuum evaporators can help you reduce these costs. And at the end, we'll show you 2 real cases where we achieved these savings and also complied with legal limits.
Condorchem Enviro Solutions.
Let's put the situation into context. Waste management costs are increasing more and more. We're talking about between 150 and 200 euros per ton. That means we're sending a large volume of water for disposal through trucks that also emit CO2, and we're not reusing that water internally. On the other hand, there's the issue of water scarcity. In some parts of the world, water availability is not very abundant. Therefore, being able to reuse water within the production cycle itself is a sustainability goal that many companies are pursuing. And finally, there's the issue of complying with legal discharge requirements. Many times are these legal limits exceeded, and thanks to being able to implement a vacuum evaporation treatment plant, we can meet these limits or even reduce discharges. Installing a vacuum evaporation system allows you to reduce those external management costs. At the same time, it obviously reduces your carbon footprint and allows you to recover that water within the production process. Let's talk about the solution. Vacuum evaporators. They operate at low pressures in order to ensure a lower boiling point. For example, in the case of heat pumps, we operate at temperatures of 35 degrees thanks to applying a very high vacuum, close to 40 millibars. This allows you to evaporate water at a very low temperature and save energy. What do we get? We get 2 effluents. One is the distillate, clean water. It's water that has been evaporated and then condensed. Therefore, it is clean and practically ready for reuse. And on the other hand, the smallest fraction of all, which is the concentrate, this is where all the contaminants remain, whether it's organic matter, salts, metals, or particles. We can recover up to 98% of the water, that is, from every cubic meter that enters the system. Practically 980 liters would be clean water that you can reintroduce into the process. And about 20 liters would be concentrate, which you would still need to manage or decide what to do with. Now let's talk about the different types of evaporators. Let's start with the heat pump. The heat pump is a piece of equipment that operates in flow ranges between 1 cubic meter per day and 50 cubic meters per day. We have 2 different models, the single effect and the double effect. The main difference is the electrical consumption. The single effect models have a certain electrical consumption, approximately 150 kilowatt hours per cubic meter, and with the double effect, we can reduce that consumption to 110 kilowatt hours per cubic meter. This is possible because we work with 2 effects and reuse the heat from the first stage to heat the second. These units are very compact. They are delivered ready to connect and start operating. Second type, thermal evaporators. Thermal evaporators are devices that operate directly with an external energy source. This can be either steam or hot water. What is the advantage of these devices? They are very robust units, mainly consisting of a boiler, a heat exchanger where we apply the steam and water, and a recirculation pump that brings the wastewater into contact with the energy source. These units can be built as single effect, double effect, or triple effect. The single effect consumes about 700 kilowatts thermal per hour. The double effect uses 400 and the triple effect 200 thermal kilowatts per cubic meter. These units are ideal if you have an external energy source, a surplus, that is cogeneration engines, or excess steam because you are already a company with a high default steam consumption. They are also very interesting in countries where the cost of natural gas or carbon sources is very cheap. Finally, since these units are very robust, they can handle a wide variability in the incoming water, so they are often very suitable for companies dedicated to waste management. Third type, mechanical vapor compression. These units are purely electric and operate at a very low vacuum, usually around 700 millibars in the evaporation boiler, which allows evaporation to occur slightly below 100 degrees, around 90 degrees, and achieve energy savings. Mechanical compression achieves this energy saving thanks to the compressor. We use a compressor that recompresses the vapor generated in the boiler electrically to reheat the rest of the residual water that remains in recirculation. This allows for a drastic reduction in electricity consumption, achieving usage between 35 and 65 kilowatt hours per cubic meter. These units are super compact and highly efficient. They are suitable for slightly concentrated waters that need to be brought to saturation, or for oily emulsions. In summary, the heat pump is suitable for small or medium flow rates, while thermal equipment is very appropriate when you have an external heat source that you can take advantage of. And mechanical compression works very well for slightly larger flow rates that require a much higher concentration, or for those that can reach a very high saturation point, and in this way save a lot on electricity. To choose the best evaporation technology in each case, you have to look at the boundary conditions, the type of water being treated, contaminants, what objectives you have for this water, whether to reuse it or discharge it, the price of natural gas, the price of electricity, and the altitude above sea level. All these factors must be taken into account to properly select the equipment. Sometimes just one evaporator is not enough. That's what crystallizers are for. Crystallizers are an evaporator, but one that is designed to produce solids. Our range of crystallizers, which we call T-salt, are offered in the same type as the evaporators. We have heat pump, thermal, and mechanical compression types. The main difference between crystallizers and evaporators is that evaporators are designed to concentrate up to saturation. So the concentrate, the small fraction we obtain, is a liquid, a very concentrated liquid, whereas in the crystallizer, the idea is to precipitate, that is, to obtain a solid. This means that electrical and thermal consumption tends to be a bit higher. For example, with the heat pump, electricity consumption can go up to 250 kilowatt hours per cubic meter, and with mechanical compression, we would be around 65 or 70 kilowatt hours per cubic meter, which changes the design. We raise the boilers so we can discharge by gravity and avoid blockages. Boiler bottoms, conical shapes, inclined heat exchangers to be able to move the solids. Crystallizers are also often used to add value to the solid, that is, if the salt contained or the product in general that we concentrate has added value, for example, pure sodium chloride, pure sodium sulfate, or an organic compound that contains nutrients that can be used as fertilizer, whether high in phosphorus, potassium, or organic matter. In this case, it is indeed worthwhile to use a crystallizer and add value to this solid. In this ideal case, we would have an evaporator that would do most of the work and produce almost all of the clean water volume, and with the concentrate from the evaporator, we would go to a crystallizer where we would further reduce the volume and obtain a solid that could be valorized. In this case, we would achieve zero discharge and could recover all the water, add value to the residue, and not discharge anything at all. On the channel, you can find a video about our Salt MVR crystallizer, where it is perfectly explained how it works. Finally, I would like to tell you about two success stories. The first is a company dedicated to the production of biofertilizers. This company was producing 2.5 cubic meters of wastewater daily. They are dedicated to producing biofertilizers in reactors, so every time they had to change the formula in the reactor, they had to wash the reactor with water. This produced a volume of water that was sent to a container, and it had to be managed. If we do the math, 2.5 cubic meters of water per day multiplied by 200 euros per ton that they were paying, we're talking about spending more than 160,000 euros each year on waste management, not counting the CO2 emissions involved in transporting this waste. What did they do? They installed a wastewater treatment plant using vacuum evaporation with a heat pump. They made an investment, and right now the current situation is that they have the treatment plant producing clean water. They recover more than 95% of the water, meaning that out of every 2.5 cubic meters, they recover about 2.3, and the rest they still manage as waste. Therefore, they have reduced their management costs by more than 10 times. From about 160,000 a year, they have reduced it to around 8,000 to 9,000 a year. To this, you have to add the cost of operating the plant, which is the electricity cost, at about 12,000 euros per year, maintenance, which is about 3,000 euros, and the management of this small amount of waste that we have managed to minimize. In total, we are talking about savings of more than 100,000 euros per year in waste management. Therefore, what has been the return on investment? In this case, just over a year. The next case is for one of our clients in the sector, Automotive. They are dedicated to aluminum die casting, which is a process by which aluminum parts are manufactured using high pressure injection. The client needed to comply with the discharge limit, which was set at 1,500 milligrams per liter of organic matter. Since they were producing wastewater with around 15,000 to 20,000 milligrams per liter, we needed to apply a treatment. The flows to be treated were high. We're talking about approximately 25 cubic meters per day, and a mechanical vapor compression unit was chosen. The goal of applying mechanical vapor compression was to minimize the energy costs of treating this water as much as possible. Fortunately, we managed to reduce the organic matter to below 500 milligrams per liter, meeting the discharge limits. In addition to this, thanks to the post-treatment we applied, the client was able to recover part of that water for floor washing and other uses. The client was able to reduce the amount of water they discharged and at the same time comply with the required limits. At Condorchem Enviro Solutions, we guarantee the most efficient, tailor-made solution for managing your wastewater. We can help you right from the very beginning by thoroughly understanding your specific needs, carefully conducting laboratory tests, designing a custom plant that best fits your objectives, and even supplying, installing, and commissioning it for you.
Condorchem Enviro Solutions.